Alright, here we are, the happiest little math book that will help you forever and ever and ever. You get the idea. Here we go. I basically split up our math book into chapters and then made a little quick guide. Okay, so chapter 1, place value, round, estimate, compatible numbers. Say you have something that says like this, round to the underlying place value. And you got this big long number, 143678924. So 143,678,924. And let's say that they want you to round to this 8, which is in the thousands place. What a lot of kids end up wanting to do is ditching those numbers, and then they round it up. But you can't. So you can't just ditch the numbers. You can't leave them. So what you're going to have to do is look at this number. I said, will the 9 make the 8 go up? So let's say we're rounding to this. You're going to look at the 9, and on our little guide here, 0, 1, 2, 3, 4s, the ball would make it roll back down to an 8. 5, 6, 7, 8, or 9s are going to make it roll to the next number. So this 9 would actually make that 8 go up to a 9. And so I wrote that down here. That 8 right there ends up turning into a 9. I'm going to copy all that other stuff that was before it, this 14367. So 14367, change that 8 to a 9. There's my changing. And then everything else turns into zeros. So that 9, 0, that 2, 0, that 4 turns into a 0. You could do that with any number, whatever place value they did. If they said, like, round it to this place, you'd copy all those numbers, and then decide, would that 4 change that? Yep. Or, no, it would stay the same. So that's a little bit of rounding. Next, standard form, all that kind of stuff. So we got the number 4543678. This is your standard form, 4,543,678. Word form, you just write out the words, what you say. I said 4 million. Now, key is look for these commas. When you find a comma, that's a place value like stop. So you've got to stop and say something. For what? 4 million. What about this? 543, comma time. So 543,000 and then 678. And I'm done. So you just group things together in groups of 3 and easy peasy. Okay, expanded form. Kids always get kind of like mixed up on this, but it's really easy. Again, use those commas for help. This 4 is a 4. I got a comma, boom. Everything else turns into 0. So 1, 2, 3, 4, 5, 6 numbers. 1, 2, 3, 4, 5, 6 zeros. Alright, put in my comma and I'm done. Plus, alright, that 5. Just write down the 5. How many numbers after it? 1, 2, 3, 4, 5. I'm going to put in 5 zeros. 1, 2, 3, 4, 5. Done. Next, 4. Write down the 4. How many numbers after it? 1, 2, 3, 4. 1, 2, 3, 4. Done. Next, 3. Write down the 3. How many numbers are after the 3? 1, 2, 3. 1, 2, 3. Now it's getting easy peasy, right? You've done this a ton of times. 6 is 600. 7 is 70. 8. There you go. Expanded form. Okay, subtraction. Just a review on subtraction. You got this number. You're going to subtract this number. You're going to go until you have a problem. 3 minus 2 is 1. No problem. 4. Problem. You can't take 5 from 4. So you look at the neighbor next door. Yay, 9. Oh, man. If I cross out that 9, that would be an 8. I can't do that. Because then that would be all messed up. So I can't borrow from him. I'm going to have to go all the way to the 3. And so that's what I wrote down here. I borrowed from the 3, made it a 2, made this a 16, but I need to borrow from it, so I turned it into a 15, turned that 19 into an 18, turned that 14. Now that 14, I'm going to stop. I'm not going to cross it out. Some kids always want to cross that out. Don't cross that out. That's why we are borrowing in the first place. So 14 minus 5 is 9. 18 minus 9 is 9, 15 minus 9 is 6, 2 minus 1 is 1, and 4 minus 2 is 2. Done. Alright. Still on place value stuff. We got this number, 51946,321, so 51,946,321. Okay, so they say, what is the value of the 4? And it's easy. You just write down the 4, doom, and then you just start counting zeros again. How many numbers after it? 1, 2, 3, 4. 1, 2, 3, 4. Done. The place value, this would be 40,000. This is in the 10,000s place because you go 1, 10s, hundreds, 1, 10s, hundreds, 1, 10, forever and ever and ever. And so that is in the thousands period. It's in the 10,000s period. All right, next. 5, find this big number, 519463212, find the value, go to the place value. Sorry, that's what I just did. Go backwards, over tens, hundreds. There it is. Ever and ever and ever. All right, so next, let's say they give you this big long number and they want you to compare. Think of it like ABC order. Go to the place value one at a time. Okay, so you want to start at the furthest to the left. If like they're tied, like super long numbers, then you're going to, compare them like ABC order. If it was like, what's 43 compared to this number, you're done. You're like, that one's obviously bigger. But they're tied. It's a 7-digit number versus a 7-digit number. So think of it like ABC order. A, B, C. So first digits, 6 and 6, they're tied. 3 versus 4, already a difference. So who's bigger? 4, bigger. Done. Easy, right? Okay, next. I did a little star thing. It says toughest place value question. That's me. I'm super strong, right? Okay, how many hundreds are in? Oh yeah, these are always the tough ones. How many hundreds are in this? So this super big long number, whatever it is. What is that? Billions or trillions? 8,432,465,789. No, I messed that up. Oh, what is that? Millions, so thousands, millions, billions. So 8,432,465,789. Okay, anyway. They want you to tell how many hundreds are there. So go to the hundreds place, which is this little 7 guy, right? Okay, just go to the place value they're asking for. In this case, it's the 7. Next, write all the numbers to the left. So 8, 4, 3, 2, 4, 6, 5. All right, so I'm going to write all that stuff down. 8, 4, 3, 2, 4, 6, 5. Boom. I'm going to put in my 7 because they were going to the hundreds place, right? So I write it all the way down to my hundreds place, and then that's it. I'm done. There are 84,324,657 hundreds in this number. Blah, 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 blah. How many 10 millions? Well, I could do the same thing. I could go to the 10 millions place. There it is. I write down 843, 843, boom, 10 millions. If you want to check, let's say that you get to a point and you're like, I think this is right, but I'm not sure. What you could do, take this long number. Let's say we're doing this guy right here. And I think it's this, 84,000 or 84,324,657 hundreds. Well, what is hundreds really? It is times 100. And so what you could do is multiply this super big long number, this 843,24657, and then multiply it by 1, and anything times 1 is itself, so you're going to get the exact same number, right? And then throw on these 2 zeros. Put on 2 zeros, and then it changes things. So 843,24657 with 2 zeros. Let's go back and put commas. Boom, boom. Are we back to originally what we had? 843. There it is. And so if you get to the point where you're like, I think this is right, but I'm not sure, multiply and check. And you could do the same thing down here. Going fast because I'm trying to get as much in as I can in a few minutes. Okay, what about multiplying? We got 473 times 9. Okay, we could blow it up, expand it. What is this 4 really worth? And it's worth 400. What's this 7? 70. What's this 3? 3. So you multiply it out. 9 times 400 is that. 9 times 70 is this. 9 times 3 is that. Add all up. Boom. Right? That is what we would call a distributive property. You're like breaking things up. All right, next one. What about this guy? You're multiplying this whole big number by this. Why is this so easy? Because you got all these zeros. I said first multiply the numbers other than 0. So I said 4734 times 2, which equals 9468. And then you just throw in the zeros. 1, 2, 3, 4. 1, 2, 3, 4. Done. All right, what about this? Let's say they give you a big problem on a test, and it says, what does this represent? So it's 6 times 400 plus 6 times 30 plus 6 times 5. What number did you keep hearing pop up? I kept hearing the 6. So it's going to be 6 times something. So it's 6 times 435, which ends up being that 2610. Okay. Another one, tough one. What is 436 or 436 10,000s? And it says write the standard number. So one easy way you could do is just go 436 times 10,000. Now some of you are, there you go, multiply it out. And so you get 436, put all your zeros, 1, 2, 3, 4 zeros, 1, 2, 3, 4 zeros, right there. So 4,360,000. Now that's one way. Another way is this, which is 436 10,000s, and I did a little hangman thing. So hangman, 3 place values, right? And it keeps going 1s, 10s, 100s, 1s, 10s, 100s, 1s, 10s, 100s, 1s, 10s, 100s, forever and ever. Now this is your units area. This is your thousands area. This is your millions area. They call them periods. But what you could do, instead of doing this multiplying, you could take your 436 10,000s. Where's the 10,000s place? Here's my thousands. Here's my 10,000s. So I said go to the last number in 436, which ends up being a 6, and put that 6 in the place value that they wanted. In this example, the 10,000s place. So there's my 10,000s place, and I put a 6. And then fill in zeros to the right. So then I put in zeros, and then there. I end up getting my same number. 4,360,000 is 436 10,000s. So I used to like it this way, the hangman way, but some kids end up liking it this way. Yeah, I don't know. Whatever you like. Okay, next. Double-digit multiplication. So we got 364 times 36. This 6 is a 1's place, so it's going to be 6 times 4, 6 times 60, 6 times 300, which ends up being 2184 for my 1's place. So basically 364 times 6 is 2184. Again, we're doing distributive property. Now this 3 is a 30, so it's going to be 30 times 4, 30 times 60, and 30 times 300, which ends up being a big number. When you add it all up, you're at 10,920. Add all that stuff up, and you're at 13,104. Now that's distributive property. That's blowing it up, breaking it apart. I would like to say that this is more real life down here. Let's say we were doing 364 times 36. You just do the 6 times the 4, which is 24. So you put a 4, carry a 2. 6 times 6 is 36, plus the 2 that you carried, so 38. Carry the 3. 6 times 3 is 18, plus 3 is 21. And so there's that 2184 that I had earlier. Okay, so now I'm going to do the 3 here, which is 30. Now to get there, this is a 30, so I'm going to go ahead and put a 0 right now to get me into that place value. So 3 times 4 is 12, carry the 1, and I put the 2, carry the 1. 3 times 6, 18, plus 1 is 19, carry the 1. And then 3 times 3 is 9, plus 1 is 10, and I didn't have anything else to carry, so I'm done. I add it up and I get the same number, 13,104. Okay, what about this? They give you like some little rectangle thing, and they say, what is this? And you're like, I don't know. Alright, so look at this whole thing, and basically you've got this section here, this rectangle here, which is like, you got a number here, you got 10 and you got a 5. So I would say that this is a 10 times a 30.